So now that we've talked about the common portions of the QuoteServices app case study, the reactive QuoteServices case study, let's talk about the structure and functionality of the Handey Microservice. And we're going to start part one of a two-part discussion. And this is going to look at the HandeyApplication, Handey Controller, and Handey Service microservice classes, which again have quite a bit in common with Project 2C. So this is going to use R2DBC 2, which we won't talk about a whole lot yet. We'll talk about that in part two, but we're going to focus more on its use of Project Reactor reactive types. So the first thing we do is we define our entry point into the Handey Microservice, and you can see we do that by making a Handey application. And this Handey application extends the base application, which is the common piece we just talked about that factors out code to avoid repeating ourselves. And you can see here we put a bunch of annotations on this class. Now, some of them are going to be very familiar. The Spring Boot application, that looks like normal. The entity scan, however, is going to go tell it to go look for the quote class, which is lurking up in the higher level parts of the common module. And then the third annotation here is really very important. It's the one that is going to enable the use of the R2DBC persistence mechanism or persistence framework. And we're going to tell it where to go find the code for that. So these annotations enable this microservice implementation to use R2DBC. And then down here, we call up to the run method from the base application, which will register this with the Eureka Discovery Service using the name HandeyApplication. Let's now talk about the Handey Controller. So the Handey Controller is going to map HTTP GET and POST requests to endpoint handlers, like any good controller does. It's a REST controller. And it auto-wires two things. Of course, it auto-wires the service. We always do that. And we also auto-wire something called an application context, which can be used for various means we'll talk about on the next slide. So this is all just good old Spring dependency injection. This method here, which is a GET method, which maps to anything that just goes to this microservice without designating any further route name. And this method is going to be used by Eureka to test connectivity. Is this microservice really up and running? And for Eureka to know that, it sends a request, and it will end up calling the info method. And then that turns around and returns a string with information about the microservice. In this case, it just says what the microservice ID is, that it's alive, and it's running at a certain thread. That's just for diagnostic purposes. The next thing we're going to talk about are some of the methods that are defined in the controller. And you can see here there's several of them. There's get all quotes, which returns all the quotes, and we'll see what it returns in a second. There's post quotes, which is going to take a list of quote IDs and then go look them up in the database and return a flux of the ones that match those quote IDs, which are the primary keys. And then finally, we show here one that does search, where you give it a list of queries, and it goes ahead and searches for that list of queries. And there's a couple other variants of this as well. What's interesting about this, and what's different from what we've seen before when we talked about the JPA version of this, is that all of these controller endpoint handler methods return fluxes to quotes. So they will be inherently asynchronous. So the moment that this is called by a client, it will return pretty much right away with the flux. And then as the database emits the elements from the flux queries or lookups or whatever we're doing here, those will be streamed back to the client asynchronously, rather than having to buffer everything up and returning it in one fell swoop. You can see we use the get mapping here to say make these be either get or post requests, and we also use other annotations like request body in order to be able to pass the list of integers or the list of strings in the body of the HTTP request that's coming across from the client. That obviously only makes sense for things that are based on posts, but it's a nice way to be able to handle that in a declarative way with annotations. Let's talk briefly about the Handey service. In retrospect, I'm probably going to revise the slides at some point. Well, I take it back. Well, we'll see. So you'll see right now we kind of follow our canonical way of doing things where we have a service, and that service is then auto-wired to the controller. It's a service, so it can do auto detection and wiring of dependent classes using class path scanning. And then it's got the Handey quote repository. So this is now going to be auto-wired by Spring's dependency injection to the database that we're about to talk about, the reactive database. Here's what the methods look like. They are very similar to the controller methods, and they return reactive types. And all they do is forward to the reactive quote repository, the Handey quote repository, to actually get those values in a reactive way. Now, because that's all they do, it would make perfectly good sense. In fact, I think I'm going to update this soon to do this, so that the Handey controller talks directly to the repository rather than being wired through a service. I'm still wrestling with whether to do that. It will disrupt the canonicality of my flow, but the reason why we can do it here and why we couldn't do it in the other examples is that these are all just complete pass-throughs. They just forward. They don't do anything other than forward. Whereas when things we've seen before, there's actually extra logic that takes place there. And in fact, that's the way your code works for assignment 2B and 2C, where you've got special logic that's lurking in some of the methods that are not entirely forwarding to the database methods. Okay, so that's the end of part 1.